Okay, now we're going to factor quadratics that have special relationships. The first one is a difference of squares, and what happens is it forms two binomials that are conjugates of each other. This is what I mean. So if you have the first term is squared and the second term is squared, when you factor it, you take the square root of the first term, which is x, and that's x times x, x squared, square root of the second term, y times y is y, but that says negative y squared. So one operator can be negative, one can be positive. And normally quadratics have three terms, and students often ask, well, what happens to the middle term? Well, the middle terms, the beauty of conjugates is the middle term cancels. I'll show you what I mean. So if you were to multiply this out, x times x is x squared, x times positive y is positive xy. Now I'm going to switch colors. Now we've taken care of the x. Now we're going to do the distributive twice with negative y. Negative y times x is negative xy. Negative y times y is negative y squared. But look at what happens right here in the middle. You have a positive xy and a negative xy. Those two cancel, leaving x squared minus y squared. So here's the process. You take, let me make this a little bit bigger. You put two sets of parentheses. You take the square root of each of those terms, put it inside the parentheses. So square root of 16k squared is 4k. We put that in there twice in the same location. As you read left to right, the beginning of the parentheses, square root of 9 goes in both sets. And then they need to be conjugates. So one needs to be a plus sign, and one operator needs to be a subtract sign. And look at that, doesn't matter which order. Okay, so this is difference of squares. It factors to two binomials that have the same numbers in them, just one's a positive, one's a negative. The second type is perfect square trinomial. And a perfect square trinomial is when the first term is squared and the second term is squared, and you're going to do the same thing. I'm going to rewrite this over here. I should have moved all of that. You put your two sets of parentheses. Square root of 16x squared is 4x. The square root, so I'll put 4x in both locations. The square root of 1 is 1. But now when it's a perfect square trinomial and it factors to a binomial squared, you take the first operator, and that first operator goes in both sets. So subtract 1. Well, if you look at inside both sets, those are the same, so you could rewrite it as 4x subtract 1 squared, just like that. All right, that's it for special relationships, factoring quadratics.